Welcome back. Michael Dickerson here on behalf of the Clay County Area Amateur Radio Club, call sign of myself, KC9PHK. Today we are on video number 4, 2019 to 2023, General Class Question Pool. Went into effect July 1st, 2019, goes all the way through to 2023. So let us begin. First question today, G3B01. What is a characteristic of skywave signals arriving at your station location by both short path and long path propagation? A. Periodic fading approximately every 10 seconds. B. Signal strength increased by 3 dB. C. The signal strength might be cancelled, causing severe attenuation. Or D. A slightly delayed echo might be heard. Correct answer here is D. A slightly delayed echo might be heard. G3B02. What factors affect the maximum usable frequency, abbreviated MUF? A. Path distance and location. B. Time of day and season. C. Solar radiation and ionospheric disturbances. Or D. All of these choices are correct. Correct answer D. All of these choices are correct. G3B03. Which of the following applies when selecting a frequency for lowest attenuation when transmitting on HF? A. Select a frequency just below the maximum usable frequency. B. Select a frequency just above the lowest usable frequency. C. Select a frequency just below the critical frequency. Or D. Select a frequency just above the critical frequency. Correct answer is A. Select a frequency just below the maximum usable frequency. G3B04. What is a reliable way to determine if the maximum usable frequency is high enough to support skip propagation between your station and a distant location on frequencies between 14 and 30 MHz? A. Listen for signals from an international beacon in the frequency range you plan to use. B. Send a series of dots on the band and listen for echoes from your signal. C. Check the signal strength on TV signals from Western Europe. D. Check the strength of signals in the MFAM broadcast band. Correct answer is A. Listen for signals from an international beacon in the frequency range you plan to use. G3B05 says, what usually happens to radio waves with frequencies below the maximum usable frequency and above the lowest usable frequency when they are sent into the ionosphere? A. They are bent back to Earth. B. They pass through the ionosphere. C. They are amplified by interaction with the ionosphere. Or D. They are bent and trapped in the ionosphere to circle the Earth. Correct answer A. They are bent back to Earth. G3B06. What usually happens to radio waves with frequencies below the lowest usable frequency? A. They are bent back to Earth. B. They pass through the ionosphere. C. They are completely absorbed by the ionosphere. Or D. They are bent and trapped in the ionosphere to circle Earth. Correct answer C. They are completely absorbed by the ionosphere. G3B07. What does LUF stand for? A. The lowest usable frequency for communications between 2 points. B. The longest universal function for communications between 2 points. C. The lowest usable frequency during a 24-hour period. Or D. The longest universal function during a 24-hour period. The answer is A. The lowest usable frequency for communications between 2 points. G3B08 says, what does MUF stand for? A. The minimum usable frequency for communications between 2 points. B. The maximum usable frequency for communications between 2 points. C. The minimum usable frequency during a 24-hour period. Or D. The maximum usable frequency during a 24-hour period. Correct answer is B. The maximum usable frequency for communications between 2 points. G3B09. What is the approximate maximum distance along the Earth's surface that is normally covered in one hop using the F2 region? A. 180 miles. B. 1,200 miles. C. 2,500 miles. Or D. 12,000 miles. Correct answer here is C. 2,500 miles. G3B10. What is the approximate maximum distance along the Earth's surface that is normally covered in one hop using the E region? A. 180 miles. B. 1,200 miles. C. 2,500 miles. Or D. 12,000 miles. Correct answer B. 1,200 miles. G3B11, what happens to HF propagation when the lowest usable frequency exceeds the maximum usable frequency? A. No HF radio frequency will support ordinary skywave communications over the path. B. HF communications over the path are enhanced. C. Double hop propagation along the path is more common. Or D. Propagation over the path on all HF frequencies is enhanced. Correct answer A. No HF radio frequency will support ordinary skywave communications over the path. G3C, ionospheric layers, critical angle and frequency, HF scatter, and near vertical incidence skywave. G3C01, which ionospheric layer is closest to the surface of the Earth? A. The D layer. B. The E layer. C. The F1 layer. Or D. The F2 layer. Correct answer is A. The D layer. G3C02, where on Earth do ionospheric layers reach their maximum height? A. Where the sun is overhead. B. Where the sun is on the opposite end of the Earth. C. Where the sun is rising. Or D. Where the sun has just set. Correct answer is A. Where the sun is overhead. G3C03, why is the F2 region mainly responsible for the longest distance radio wave propagation? A. Because it is the densest ionospheric layer. B. Because of the Doppler. C. Because it is the highest ionospheric region. Or D. Because of meteor trails at that level. Correct answer is C. Because it is the highest ionospheric region. G3C04, what does the term critical angle mean as used in radio wave propagation? A. The long path azimuth of a distant station. B. The short path azimuth of a distant station. C. The lowest takeoff angle that will return a radio wave to Earth under specific ionospheric conditions. Or D. The highest takeoff angle that will return a radio wave to Earth under specific ionospheric conditions. Correct answer is D. The highest takeoff angle that will return a radio wave to Earth under specific ionospheric conditions. G3C05, why is long-distance communications on the 40 meter, 60 meter, 80 meter, and 160 meter bands more difficult during the day? A. The F layer absorbs signals at these frequencies during daylight hours. B. The F layer is unstable during daylight hours. C. The D layer absorbs signals at these frequencies during daylight hours. And D. The E layer is unstable during daylight hours. Correct answer is C. The D layer absorbs signals at these frequencies during daylight hours. G3C06, what is a characteristic of HF scatter? A. Phone signals have high intelligibility. B. Signals have a fluttering sound. C. There are very large sudden swings in signal strength. Or D. Scatter propagation occurs only at night. Answer is B. Signals have a fluttering sound. G3C07, what makes HF scatter signals often sound distorted? A. The ionospheric layer involved is unstable. B. Ground waves are absorbing much of the signal. C. The E region is not present. Or D. Energy is scattered into the skip zone through several different radio wave paths. Answer D. Energy is scattered into the skip zone through several different radio wave paths. G3C08, why are HF scatter signals in the skip zone usually weak? A. Only a small part of the signal energy is scattered into the skip zone. B. Signals are scattered from the magnetosphere, which is not a good reflector. C. Propagation is through ground waves, which absorbs most of the signal energy. Or D. Propagation is through ducts in the F region, which absorbs most of the energy. Answer is A. Only a small part of the signal energy is scattered into the skip zone. G3C09, what type of propagation allows signals to be heard in the transmitting station's skip zone? A. Faraday rotation. B. Scatter. C. Chordal hop. Or D. Short path. Correct answer is B. Scatter. G3C10, what is near vertical incident skywave propagation? A. Propagation near the maximum usable frequency. B. Short distance MF or HF propagation using high elevation angles. C. Long path HF propagation at sunrise and sunset. Or D. Double hop propagation near the lowest usable frequency. Correct answer is B. Short distance MF or HF propagation using high elevation angles. G3C11. Which ionospheric layer is the most absorbent of long skip signals during daylight hours on frequencies below 10 MHz? A. The F2 layer. B. The F1 layer. C. The E layer. Or D. The D layer. Correct answer is D. The D layer. Moving on, subelement G4, amateur radio practices. First up, G4A, station operation and setup. G4A01 says, what is the purpose of the notch filter found on many HF transceivers? A. To restrict the transmitter voice bandwidth. B. To reduce interference from carriers in the receiver passband. C. To eliminate receiver interference from impulse noise sources. Or D. To enhance the reception of a specific frequency on a crowded band. Correct answer B. To reduce interference from carriers in the receiver passband. G4A02. What is one advantage of selecting the opposite or reverse sideband when receiving CW signals on a typical HF transceiver? A. Interference from impulse noise will be eliminated. B. More stations can be accommodated within a given signal passband. C. It may be possible to reduce or eliminate interference from other signals. D. Accidental out-of-band operation may be prevented. Correct answer is C. It may be possible to reduce or eliminate interference from other signals. G4A03. What is normally meant by operating a transceiver in split mode? A. The radio is operating at half power. B. The transceiver is operating from an external power source. C. The transceiver is set to a different transmit and receive frequencies. Or D. The transmitter is emitting an SSB signal as opposed to a DSB operation. Correct answer is C. The transceiver is set to a different transmit and receive frequencies. G4A04. What reading on the plate current meter of a vacuum tube RF power amplifier indicates correct adjustment of the plate tuning control? A. A pronounced peak. B. A pronounced dip. C. No change will be observed. Or D. A slow rhythmic oscillation. Answer is B. A pronounced dip. G4A05. What is the reason to use automatic level control, ALC, with an RF power amplifier? A. To balance the transmitter audio frequency response. B. To reduce harmonic radiation. C. To reduce distortion due to excessive drive. Or D. To increase overall efficiency. Answer is C. To reduce distortion due to excessive drive. G4A06. What type of device is often used to match transmitter output impedance to an impedance not equal to 50 ohms? A. Balanced modulator. B. SWR bridge. C. Antenna coupler or antenna tuner. Or D. Q multiplier. Correct answer is C. Antenna coupler or antenna tuner. G4A07. What condition can lead to permanent damage to a solid-state RF power amplifier? A. Insufficient drive power. B. Low input SWR. C. Shorting the input signal to ground. Or D. Excessive drive power. Answer D. Excessive drive power. G4A08. What is the correct adjustment for the load or coupling control of a vacuum tube RF power amplifier? A. Minimum SWR on the antenna. B. Minimum plate current without exceeding maximum allowable grid current. C. Highest plate voltage while minimizing grid current. D. Maximum power output without exceeding maximum allowable plate current. Answer is D. Maximum power output without exceeding maximum allowable plate current. G4A09. Why is a time delay sometimes included in a transmitter keying circuit? A. To prevent stations from interfering with one another. B. To allow transmitter power regulators to charge properly. C. To allow time for transmit-receive changeover operations to complete properly before RF output is allowed. Or D. To allow time for a warning signal to be sent to other stations. Correct answer is C. To allow time for transmit-receive changeover operations to complete properly before RF output is allowed. G4A10. What is the purpose of an electronic keyer? A. Automatic transmit receive switching. B. Automatic generation of strings of dots and dashes for CW operation. C. Vox operation. D. Computer interface for PSK and RTTY operation. Correct answer B. Automatic generation of strings of dots and dashes for CW operation. G4A11. Which of the following is the use for the IF shift control on a receiver? A. To avoid interference from stations very close to the receive frequency. B. To change frequency rapidly. C. To permit listening on different frequencies from that on which you are transmitting. D. To tune in stations that are slightly off frequency without changing the transmit frequency. Answer here is A. To avoid interference from stations very close to the receive frequency. G4A12. Which of the following is a common use for the dual VFO feature on a transceiver? A. To allow transmitting on two frequencies at once. B. To permit full duplex operation, that is, transmitting and receiving at the same time. C. To permit monitoring of two different frequencies. Or D. To facilitate computer interface. Answer is C. To permit monitoring of two different frequencies. G4A13. What is one reason to use the attenuator function that is present on many HF transceivers? A. To reduce signal overload due to strong incoming signals. B. To reduce transmitter power driving a linear amplifier. C. To reduce power consumption when operating from batteries. Or D. To slow down received CW signals for better copy. Answer is A. To reduce signals overload due to strong incoming signals. G4A14. What is likely to happen if a transceiver's ALC system is not set properly when transmitting AFSK signals with the radio using single sideband mode? A. ALC will invert the modulation of the AFSK mode. B. Improper action of the ALC distorts the signal and can cause spurious emissions. C. When using digital modes, too much ALC activity can cause a transmitter to overheat. Or D. All of these choices are correct. Correct answer is B. Improper action of the ALC distorts the signal and can cause spurious emissions. G4A15. Which of the following can be a symptom of transmitter RF being picked up by an audio cable carrying AFSK data signals between a computer and a transceiver? A. The Vox circuit does not unkey the transmitter. B. The transmitter signal is distorted. C. Frequent connection timeouts. Or D. All of these choices are correct. Correct answer is D. All of these choices are correct. G4A16. How does a noise blanker work? A. By temporarily increasing received bandwidth. B. By redirecting noise pulses into a filter capacitor. C. By reducing receiver gain during a noise pulse. Or D. By clipping noise peaks. Correct answer is C. By reducing receiver gain during a noise pulse. G4A17. What happens as the noise reduction control level in a receiver is increased? A. Received signals may become distorted. B. Received frequency may become unstable. C. CW signals may become severely attenuated. Or D. Received frequency may shift several kilohertz. Answer is A. Received signals may become distorted. G4B, covering test and monitoring equipment and the two-tone test. G4B01. What item of test equipment contains horizontal and vertical channel amplifiers? A. An ohm meter. B. A signal generator. C. An ammeter. Or D. An oscilloscope. Answer is D. An oscilloscope. G4B02. Which of the following is an advantage of an oscilloscope versus a digital voltmeter? A. An oscilloscope uses less power. B. Complex impedances can easily be measured. C. Input impedance is much lower. Or D. Complex waveforms can be measured. Answer is D. Complex waveforms can be measured. G4B03. Which of the following is the best instrument to use when checking the keying waveform of a CW transmitter? A. An oscilloscope. B. A field strength meter. C. A side tone monitor. Or D. A wave meter. Correct answer is A. An oscilloscope. G4B04. What signal source is connected to the vertical input of an oscilloscope when checking the RF envelope pattern of a transmitted signal? A. The local oscillator of the transmitter. B. An external RF oscillator. C. The transmitter balanced mixer output. Or D. The attenuated RF output of the transmitter. Answer is D, the attenuated RF output of the transmitter. G4B05, why is high input impedance desirable for a voltmeter? A, it improves the frequency response. B, it decreases battery consumption in the meter. C, it improves the resolution of the readings. Or D, it decreases the loading on circuits being measured. Answer is D, it decreases the loading on circuits being measured. G4B06, what is an advantage of a digital voltmeter as compared to an analog voltmeter? A, better for measuring computer circuits. B, better for RF measurements. C, better precision for most uses. Or D, faster response. Answer is C, better precision for most uses. G4B07, what signals are used to conduct a two-tone test? A, two audio signals of the same frequency shifted 90 degrees. B, two non-harmonically related audio signals. C, two swept frequency tones. Or D, two audio frequency range square wave signals of equal amplitude. Answer is B, two non-harmonically related audio signals. G4B08, which of the following instruments may be used to monitor relative RF output when making antenna and transmitter adjustments? A, a field strength meter. B, an antenna noise bridge. C, a multimeter. Or D, a Q meter. Answer is A, a field strength meter. G4B09, which of the following can be determined with a field strength meter? A, the radiation resistance of an antenna. B, the radiation pattern of an antenna. C, the presence and amount of phase distortion of a transmitter. Or D, the presence and amount of amplitude distortion of a transmitter. Answer is B, the radiation pattern of an antenna. G4B10, which of the following can be determined with a directional watt meter? A, standing wave ratio. B, antenna front to back ratio. C, RF interference. Or D, radio wave propagation. Answer is A, standing wave ratio. G4B11, which of the following must be connected to an antenna analyzer when it is being used for SWR measurements? A, receiver. B, transmitter. C, antenna and feed line. Or D, all of these choices are correct. Answer is C, antenna and feed line. G4B12, what problem can occur when making measurements on an antenna system with an antenna and analyzer? A, permanent damage to the analyzer may occur if it is operated into a high SWR. B, strong signals from nearby transmitters can affect the accuracy of measurements. C, the analyzer can be damaged if measurements outside the handbands are attempted. Or D, connecting the analyzer to an antenna can cause it to absorb harmonics. Answer is B, strong signals from nearby transmitters can affect the accuracy of measurements. G4B13, what is a use for an antenna analyzer other than measuring the SWR of an antenna system? A, measuring the front-to-back ratio of an antenna. B, measuring the turns ratio of a power transformer. C, determining the impedance of coaxial cable. Or D, determining the gain of a directional antenna. Correct answer here is C, determining the impedance of coaxial cable. G4B14, what is an instance in which the use of an instrument with analog readout may be preferred over an instrument with a digital readout? A, when testing logic circuits. B, when high precision is desired. C, when measuring the frequency of an oscillator. Or D, when adjusting tuned circuits. Answer is D, when adjusting tuned circuits. G4B15, what type of transmitter performance does a two-tone test analyze? A, linearity. B, percentage of suppression of carrier and undesired sideband for SSB. C, percentage of frequency modulation. Or D, percentage of carrier phase shift. Correct answer is A, linearity. And that will conclude the fourth video in this series. I thank you again for joining us. Don't forget to subscribe so you're getting notified of those new videos as we release them.